Okay, good day. So we're looking at investments and loans involving annuities. Okay, so we need to understand what an annuity is. An annuity is a series of equal payments, investment payments, or loan repayments at regular intervals, subject to a rate of interest over a period of time. So what you pay like monthly or quarterly or every year, you're paying a same amount. Let's say you borrowed money, and now when you borrow money, you need to repay them the loan. And how do you pay the loan? You are paying in equal installments. Now, when you pay equal installments, those installments are called annuities. Okay, so when you are investing money, you use what you call, you are trying to achieve or trying to attain a certain value. You want a certain value in future. So what we call it, we use what we call future value annuity. So what you're doing, you are saving money, maybe for the college, or you're saving money, maybe for, should I say maybe for marriage, for wedding, okay? That's what you're saving for, or for lobola. So what you're doing, you're putting money, what's called saving, maybe equal payments into the bank, so that the bank can save for you. Then you can take it, what called as a lump sum later on. Now, whenever you see the word investment or saving, you must work with future value formula. Okay. Then when you're talking of present value, whenever you see loan or someone borrowing money, what you see there is you're borrowing a amount of money that is there already. So you already know the amount that you are borrowing. So we use what we call present value. But we're going to focus first now on what we call future value annuities. Okay. So future value annuity, money invested at regular intervals in order to save money for the future. I think I've explained that. Now, we have what we call annuity due or annuity, ordinary annuity. Now, remember this now. When you're making your payments, you can make your payments end of each month, or the beginning of each month, or the beginning of each period, should I say, because you don't pay monthly only. You can pay quarterly, or you can pay yearly, but you're saying your payments, you can make them at the end of each period or at the beginning of each period. So when I'm saying annuity due, these are payments made at the beginning. So these are immediate payments. So we can call them immediate payments. Immediate payments. Okay, so ordinary annuity, these are payments made at the end of each period. Now, you just need to understand this. I will show you why you need to understand this. Now, future value formula, these are future value formula. This is how FV represents future value is equal to X. These X are equal payments that you pay what we call it on a regular basis. Then N is the number of payments. Then your interest, your I is your interest. Okay, so this is our formula for what is it for future value. Okay. Now let's check here. Annuity due or immediate payments yield more money. Now I want to know how come. Now let's say you are making payments, 4 payments made over 4 years. So what we have here, I'm just going to draw a timeline here. Now I'm just going to draw a timeline, and the timeline here consists of what? 4 payments. So we're saying it's okay. So we're saying we have got T0. So T0, beginning of the month. Let's say beginning of the year. Then we're saying end of the year. We are saying we've got 1 year. At the end of the 2 year, we are saying we've got 2 years. We have got third year. Then we've got what? 4th year. Then we're gonna do the same here for what is it for ordinary annuity. We just want to show you here. Then what we have here, we have got T1, T0, T2, T3, and T4. Let me write this on top there so that I can have much space here. So what I have done here, I've shown, I've just changed here T0, T1, T2, T3, T4. So this is marking the end. So we are saying T0, we are not saying we haven't started the year, it's 1 January. What do? You make a payment. So when you make that payment, what's going to happen to that payment? That payment is going to grow for how long? Because you're going to need it for, you're going to take that money for what is it? For what is it? For at the end of what? End of 4th year. So here what has happened here. So let me just show you. I'm just going to put a dot here. Okay, then this is where you're going to end. That's where your last payment will be. So we're saying you make the second year, the first end of what will beginning of second year, you make a payment again that grows to here. Just want to show you, I just want to indicate up to here, guys. The reason for that. Now, then here, third year, which is beginning of a third year, you make a payment here. Then beginning of fourth year, you make a payment again. But here's the thing now, you're going to collect your money at the end of the fourth year. So what happens that your money is going to increase now. It's going to grow. This money here is going to give an extra month to grow. Again, this month they've got an extra month to grow. Again, this money here is going to have an extra month to grow. Then this month that we're going to pay in the fourth year is going to grow for a month. So you have this amount growing for 4 years. This one is growing for how many years? So it's going to be 1, 2, 3, 4. Okay, this one growing for 3. This one growing for 2. This one growing for 1 year. That's what you're having here. So you, in other words, you have more money here at the end of the fourth year. Now, what about ordinary annuity now? Ordinary annuity, you are making a payment at the T0, you're not paying anything beginning of the year. You are paying in December at the end of the year. So in T1, we are saying here, that's where you start making your payment here. Make a payment, that's your first payment. Then you make a second payment. You make a third payment. Then you make the last payment. So this money have got 3 years to grow. This money have got 2 years to grow. But this money also, you have got what? 2 years, 1 year to grow. And the fourth payment, it's not going to grow. This one is not going to grow. This one, no grow. It won't grow. 0. So your last payment, you paid on the day or on the period that you're going to take out your money. So that's why I'm saying it's not going to grow here. So in other words, this money here have got 3 years to grow. So you find that you have more money when you start paying beginning of each month than here, where you are having beginning of the month here. Sorry, end of the month, end of the period. Sorry. So now what we're having here is that you must understand something here. When now we are going to face such situations where we are saying annuity due, you have to pay, say, N+1. But now, where now do we do that? We do that only if we are saying you start paying here and they pay until the end of the period. So you pay, when you make an extra payment here, it means that you're going to make 5 payments. I'm going to make you understand when you do questions. Okay, so let's try now to attempt some questions that you face. Now, we're going to try to do number 2. Now, John deposited 500 into savings account at the end of each month thereafter. At the end of each month thereafter, he deposits 500 into the account and he continues to do this for 6 years. Interest is 7% per annum compounded monthly. Calculate the future value if his investment end at the end of 6-year period. Now, what we are saying is that you start to make payment here at T0. When you start to make payments at T0, because this one we are saying you deposit money and you start paying at the end of each month. So you make it T0. So it means that whatever years that we're going to have, months that we're going to have here, we are going to say, let's say just maybe, let's say this was maybe 5 months. So 5 months, in 5 months, what we are saying in 5 months, if this person is going to pay in 5 months, it means that in 5 months we've got T1, T2, T3, T4, and T5. But his payments, how many payments will he make? He's gonna make this, he's gonna make these payments here at T0 because he's making the payment, the deposit already is T0. Then at the end of each month, he's paying here, he's paying again. He's paying again here, he's paying again here, he's paying again here, and he's paying again here at the end of the month, of 50 month. So how many payments did he make? 1, 2, 3, 4, 5, 6. So you find that you will say N, which is your 5, plus 1 to get 6 now. So you use N plus, you have an extra payment there because he is finishing payments at the end of the 6-year period. That's what you need to understand there. So, okay, let's check here. Now, we use our formula FV is equals to what? X in bracket 1 plus I to the power of N minus 1 over I. Now, what is our X? Our X is 500. What is our N? Our N is going to be equal to, we are saying 6 years, so it's going to be 6 times 12, because we are saying 12 months plus 1. So it's going to be 6 times 12 plus 1, we get 73. Not 72, because if you have to say 6 times 12, you get 72. Now, when you use 72, you're not going to, you didn't make 72 payments. That's the problem. So let's move on here. What is our I? Our I is equal to what? 7%. Compounded monthly. When you compounded monthly, what do? We say 7% over 12, which is going to be 7 over 1200. 7 over 1200, because saying 7% is 7% means that 7 over 100. So here 7 over 1200. Or you can put it like this. You can say 0.07 over 12. It's still the same way. It's still the same. It's still the same, guys. You don't have to stress much. It's still the same. You still get the same answer. Now, what else do we want here? We are looking for FV. Okay, now let's put our values here. What is our X? X is going to be equals to 500. Or maybe it's too squashed here. Let me just say FV is going to be equals to 500 in bracket 1 plus, what is our I? 7 over 1200 to the power of what? 73 minus 1. We close that. We over 7 over 1200. Okay, we'll put that in bracket. Okay, now we come here and punch our calculator. What do we have today? We have got punch there, put our let's put 3, then we're gonna say 1 plus 7 over 1200. We close the bracket to the power of 73 minus 1. We close the bracket. You need to put 2 brackets there. Then what do we have? We're gonna put 7 over 1200. Or then what do we get there? We get 90. Did I put 500 there? Let me check. Was there something wrong? Can't you have 90 there? I didn't put anything there. Okay, forgive me for that. 500. Okay, the amount that we are paying. So it's gonna be 45,300. So it's gonna be equal to 45. It's in rands. 45,340,52. Always leave your answer in two decimal places. Okay. Always leave your answer to two numbers after the comma. Okay. Now, let's move on again to the next question. Nandile deposit 1,800 into savings account. At the end of each month thereafter, she deposits 1,800 into the account and continues to do this for 10 years. Interest rate is 8% per annum, compounded monthly. Calculate the future value of her investment at the end of 10-year period. Once they say he deposits the money, she deposits the money, this is the beginning. Then at the end, when they write this, you know, and he's going to pay at the end of the period. He's going to finish this investment at the end of the period. Then you know that, no, this person is already making 2 payments in the first month. So you must make sure that you say whatever end that you get plus 1. Okay. So what do we do now? We know we're going to say this was number 2. We are going to move on to number 3. Number 3 now, we are writing our formula again. Or should we? Let me just write FV is equals to X 1 plus your I, the power of N minus 1 over I. Now, what do we have here? What are we given? We are given X. X is what? 1,800. What is our N? Our N is equal to, for how many years? For 10 years. And we are saying 10 years because it's compounded monthly. Compounded monthly, we are going to worry there times 12. How many months in a year? Is 12 months. So we are saying it's going to be 12 times 10. But again, once you say times 10 plus 1, 121, that's your what you call number of period. That's your N. Then what else do we need there? Our I is equal to what? Our I is 8% per annum compounded monthly, 8 over 1,200. Okay, 8 over 1,200. Then what is our FV now? Our FV is going to be equals to 1,800 bracket 1 plus 8 over 1,200, the power of 121 minus 1. We close that over. What are we saying over to? Over to our interest, which is 8 over 1,200. Okay, then what do we get now? Let's punch our calculator. Punch our calculator. We have got 1,800. Don't forget to put the money before. Then you put 3 brackets there. We are opening. Then once you start doing that, you first write 8 over 1,200. Because the reason I'm putting 3 brackets is because we need to close them. Well, when you close this, this is going with this bracket here. I'm going to show you. Then what do we have here? We have got to the power of 121 minus 1. We close with the 2 now because we are remaining with the 2, so that to make them 3, 1, 2, 3. The other side is 3 also. Then we go down there. We close the bracket there. It's down 8 over 1,200. Then what do we get? We get our answer is what? 333. 333,298,22. Because of the 5 there, it's going to add 1 there. It's going to be 22 right. Okay. Okay, let's go to the next question, guys. Now, these questions, the reason why I didn't finish them is because what is it? You need to understand this, and you need to do this, and the answers are there already. Okay, so that's your part of your homework. Michael deposit 10,000 into savings account at the end of each period, each year. At the end of each year, you already deposit. At the end of each year now, thereafter, he deposit 10,000 into the account, and he continues to do this for 20 years. Interest is what? Is 18% per annum effective. When you say per annum effective, it means that it's per annum per year. Effective, remember, effective interest. If you still remember what we have done with effective interest and what is it, and nominal. Now here, calculate the future value of the investment at the end of the 20 year. Okay, so you must know that N. I'm just gonna do this for you, just for you to know that N. Don't forget that your N is gonna be equal to what? How many years do we have there? We are told that is 20 years. 20 years plus what? 1. Your interest is just gonna be 18%, 18 over 100, because it's per year. We are not compounding per year. Then Pauline decided to start saving money for a period of 12 years, starting on 31 December 2011. At the end of January 2012, in 1 month time, she deposits 2,500 into the savings account. Thereafter, she continues. I think the question there is not there. Sorry about that. Okay. Then let's move on to the next question. Pod pays 3,000 into an 8-year savings account at the end of each month, starting 3 years after his decision. Now, the interest is 18% per annum compounded monthly. If the investment period starting from his decision to start saving is 8 years, calculate the future value of the investment at the end of the eighth year. Now, here is the tricky part here, guys. This guy here thought of doing saving money, 3,000, each month. But his decision, he made it today. Then in 3 months after, 3 months later, that's when he decided to say, you know what, that's when he started depositing the money, not deciding. Deciding is decided 3 years before. So guys, let's start here. I want you to make understand something here. FV is equal to X. Just gonna start by writing formula here. 1 plus your I. This is very much important because you get your mark for the formula. Knowing what to use is a free mark there. Now, there we have our, the power of n. Imagine if you forgot n there, you won't get a mark. Now, here, let's have our x. Our x is 3,000. This is our installment. Now, what is our I? Our I there is compounding monthly. It's going to be 18 over 1,200. Okay? But let's check our n here, the tricky part there. Our n now, since now, we are going to say, all right, 8 years times 12, 8 years times 12. 8 years times 12, remember here, this is another tricky part here. This guy here is going to start paying in 3 months and is paying end of each month. So when you say end of each month, it means that 3 years, we're going to subtract 2 years. Going to say minus 2 years. Because we are saying if he's going to pay end of each month, it means that he's starting end of. So you're saying T0, T1. So if I say T0, T1, T2, T3, T4, like that. So I want you to understand something. He is not paying here. He is not paying here. At the end of T2, he is starting paying here. So we're going to say minus 2 months, minus these 2 months here, because he's starting to pay 3 months after. Because remember, this T0 means the beginning of the month, end of the month, end of the month, end of the 3rd month. That's when he starts to pay. So we're saying minus 2. So here we're going to say 8 times 12 minus 2. Don't worry about where he started to make this decision. Don't worry about he's not making any payment, this guy. He just decided he didn't make any payment, so you must watch out that. Those are the trick part that got you guys. So we're going to say 3,000. 1 plus our I is 18 over 1,200 to the power of 94 minus 1 all over 18 over 1,200. Now, what do we get there? Let's punch our calculator. Remember, 3,000, 3 brackets, 1 plus our I is 18%, 18 over 1,200, close bracket to the power of 94 minus 1. Okay, we close the bracket is 2. We go down there, we say 18 over 1,200. Close the bracket there. What do we get? We get, don't forget to write the units as well. Well, these are not cows. You need to indicate that it's in rands. It's not in pounds, or it's not in 0.55. Okay, 0.55. Also, guys, know how to round off. Know how to round off. When you're rounding off to decimal places, on your second digit that you need to work with, check the number after that. If it's above 5, you add 1 there. Please don't forget to do that, because some of you make those mistakes. You already got your answer. Now you're making the last mistake. Hey guys, please make sure that you check the number after the second decimal. You check it. If it's above 5, you add 1 day. If it's not above 5, you just remain like that. Okay. Now let's move on. Next question. Now, Simon starts saving money in a unity trust fund. Okay. He immediately deposits 900 into the fund. Thereafter, at the end of each month, he deposits 900 into the fund and continues to do this for 5 years. Okay. Now, interest is 18% per annum compounded monthly. So we are going to deal with this. Guys. Let's deal with this. Now, calculate the future value of his investment at the end of the 5-year period. Again, that end you must worry about. Now, what do we do now? We're going to say, Simon, for this one here, he invests what? FV is equals to X, 1 plus your I minus 1. Okay. Then what do we get there? We're going to say, all right, now what do we have here? We have our X, our I, then our N. Our N here, again, we are going to say, okay, how many years? 5 years. 5 times 12 plus what? Plus 1. Because we are told that he started to pay at the end of each month thereafter. Okay, the end of each month, he started depositing. Once we see that it's a red flag, 5 times 12 is 60 plus 1 is 61. Then what do we do here? We put our values 900, 1 plus 18 over 100 over 1200 to the power of what? To the power of n is 61 minus 1 over I. I is what? 18 over 1200. Let's punch that in our calculator. Put our 3 brackets. No, before that, 900, 3 brackets, 1 plus 18 over 1200 to the power of 61 minus 1. Okay, 18 over 1200. Then what do we get now? We get 88,792,08. What is it? It's not pounds, it's not what you call any other currency, it's rands. So you must indicate that. Now, so that's your A. Then let's move on to B. Simon leaves his money in the fund to grow for 2 years without making any further payment of 900. The interest rate changes to 10% per annum compounded quarterly. Calculate the value of his investment after the 2-year period. Now, he decided to leave the money. Which money now? This money. For how long? For 2 years. Now, here's the trick now. This one now is going to compound because he's not making any other payments. This is going to compound, it's going to what called increase. How does it increase? It increases using the formula of A is equals to P1 plus I compound formula. What is our A? Our A is the one that we want. What is our P? Our P is the principal, which is this amount. So it's going to be 88,792,08. I like putting the values. I don't have to round off when I'm dealing before I find my final answer now. I round off here because this is the final answer, but now I need to use that here. Now, what is our I? Our I. Now, guys, remember how many times a year? 4 times a year because it's quarterly, compounding quarterly. So it's going to be 10 over 400 because it's 4 times a year, 400. Now, what do we have here? We've got what else do we need? Our N. Our N, we are saying is for how long? For 2 years. 2 years times what? Times 4, because we are saying 4 times a year is going to be 8. So now we just put our values here. Our A is going to be equal to P88,792, 0.0834 in bracket. What do we have? 1 plus, what is our I? 10 over 400 to the power of what? 8. What do we get? What do we get after that? Let's check what we get there. It's okay. We're gonna say answer times. We're gonna put in brackets 1 plus 10 over 400. We close the bracket to the power of 8. We see this man here will be having 108,184,000,53. What is it? It's in rands. Okay, so I hope you guys understand this part of what is it, future value, and I wish you the best. Okay, thank you so much. The next lecture will be on present value. Okay, so once you see investment, saving, you know that it's future value. We want to attain a certain amount in future. Then we're going to talk about loan. Then we need to deal with present value. Okay, thank you so much.